Welcome to our review on titrations. So the first thing we really need to know is what actually is a titration. So when we're talking about titration, what we're referring to is the method that we're going to use to determine the concentration of an acid or an alkali through using a neutralization reaction. And in order to do this, we need to use a certain type of indicator. Now, you're quite used to using universal indicator in school for a range of reactions because it shows a whole range of different colours depending on the pH, but that's pretty useless when it comes to titrations. The type of indicator we want to use is called a single indicator, and the most common example you've probably used in school is phenolphthalein. Now, the whole idea of using this single indicator is it has just one colour change. So it gives you that really clear endpoint so you know exactly when it's been neutralised. So because titration is one of these assessed practical tasks, we do need to know how to actually carry it out. So the first thing you need to do is to fill the burette with acid. Now, a couple of safety features here. First of all, you put a funnel in the top so that you're not pouring acid from a container into a narrow tube, so it minimises spillage. You'll always place it on the floor so it's not pouring acid above your head, and you'll also wear goggles. So once you fill the burette with acid, you then use this bit of equipment called a volumetric pipette, which is the one with the little pipette filler, so you get a really accurate measure. And we use that volumetric pipette to transfer 25 centimeters cubed of our alkali, which in all likelihood is sodium hydroxide. And then once we've measured that, we place it into the conical flask. Next thing we do is we just add a very small number of drops of our single indicator to the flask, and it's a small number because we don't need large quantities there. You are then going to place that under your burette and you record your start volume. In all likelihood for your first titration, it's going to be starting on 0. Then what you do is you open the tap and you gradually add the acid from the burette to our conical flask until it just changes colour. And once it's just changed colour, that's the end point of your reaction. So that's where you're going to record the end volume, and then you can work out the difference between the start volume and the end volume to give you your titer. Now, we don't just do a titration once and just hope for the best. What you're going to do is you're going to repeat that method until you have what's called concordant titers. Now, this means that you've actually got readings that are within 0.10 centimeters cubed of each other, so incredibly close to each other. What's in all likelihood going to happen here is you'll do your first one, which is your rough titration, and it gives you a vague idea of where you're actually going to come out. Then the second time you do it, you know roughly where the colour is going to change, so at that point you're going to go much slower and add it a single drop at a time. Now, we've used this word titer a few times, and quite simply all that is the measured volume of solution that we're adding from the burette during a titration to reach that end point, so that colour change with our single indicator. So when we're carrying out titrations, there are basically 3 indicators that we're likely to use. First one we've heard of before, litmus. Now that one is red in an acid solution and blue in alkaline. Phenolphthalein, this is colourless in an acid, but it goes this very clear pink colour when it's in an alkaline. Methyl orange is our third and final one, which is red in acid again, but it goes yellow in an alkaline solution. So make sure you do know those different indicators and the colours they go both in acid and alkaline solutions. One thing we use when we're carrying out titrations is something called a standard solution. Now, our standard solution actually has this accurate concentration, and that's why we're going to use it in titrations, because we know the exact concentration of that solution. So when we're then trying to work out an unknown concentration, we've got to have the utmost accuracy. So if you were looking to make your standard solution of sodium hydroxide, quite simply you'd start off by measuring 1 gram, for example, of our sodium hydroxide, and then you dissolve it in about 150 centimeters cubed of water in a beaker. Now, obviously that's not very accurate at this point, but we then pour that solution into a 250 centimeter cubed volumetric flask. And then you just add water to reach the 250 centimeter cube mark, and then that gives you a very accurate concentration in your standard solution. The 2 bits that we're making sure are very accurate there is the volume of water by using that volumetric flask, and obviously the mass of our sodium hydroxide at the beginning by using an accurate balance. So when we're thinking about accuracy here, the first thing that we need to consider is how we're going to measure the volume of our solution to go in our conical flask. Now, the most common bit of equipment that you're probably thinking about is a measuring cylinder. And yes, that will give us 25 centimeters cubed, but it's not as accurate as the volumetric pipettes that we've mentioned. So we'd always use a volumetric pipette to give us the increased accuracy. The second thing we need to do to make sure that we're having the utmost accuracy in our actual titration is to make sure that when we've clamped the burette, it is actually vertical. And I know that when I've seen you do these titrations in the experiments themselves, then your burettes are a little bit wonky, and that means that when you're trying to read the volume, it's not going to be a nice clean horizontal line. So make sure the burette is clamped vertically to give you those accurate results as well. The other thing to consider is what you're actually looking at in terms of reading that burette. So when you look at any liquid within a cylinder, then it's not just a perfect horizontal line. You actually get a little curve called the meniscus. Now, you always read the meniscus from the very bottom of that curve itself. So what we need to do is make sure that your eye level is in line with the bottom of the meniscus, and you always read from that bottom point. Whenever we're looking at this, we're going to record it to 2 decimal places. So if the bottom of the meniscus actually falls onto a line, then our second decimal place will be a 0. But if it's between 2 lines on our actual scale on the burette, then that second decimal place will be a 5. Next thing we should do to actually ensure that we've got an accurate titration going on is you should have constant swirling of the flask during the titration. So this requires a certain amount of dexterity to be able to control the tap and swirl the flask underneath it without pouring acid all over your hands. But if you don't have it swirling all the time, what you'll find is the contents doesn't mix, and therefore you might think it's changed colour, but as soon as you then give it a swirl, the colour vanishes. The last thing we need to do to ensure accuracy is as we approach that endpoint, you don't run it through as a constant stream from the burette. You need to add it a drop at a time, because that gives you the most accurate result. Hopefully by the end of this revision video you do know what a titration is and how to carry it out. You should also know what a single indicator is and the different colours and examples that we've used. You should also be able to talk about how we can improve accuracy in these titration experiments.